All right. Welcome to the EMU session at IETF 102. Hey.
Hey, okay?
I think everything's good. So the big piece of news to announce is we have a co-chair. Mohit has agreed to co-chair with me. Appreciate that. So has anybody not seen the note well yet? Just raise your hand if you haven't seen the note well. You guys are jokers, I can tell. So hopefully you have actually seen this. So we'll move on. So we have minute takers and Jabber scribes. The blue sheets are going around. Remember to always state your name at the mic. And we haven't had too much problems with people being non-professional in this group. So I don't think that's too much of a problem, but just remember, we're all working for the same thing. So for the agenda, we have a couple topics that have to do with ETLS, then a couple topics that have to do with AKA, and then I believe we'll have some time at the end to kind of get an update on some using TEEP with Anima and Brewski. So we'll see if we have time for that at the end. I think we probably will, but we want to spend more time on the working group documents and documents that we're going to be taking into, hopefully that are part of our charter. So right now we have using ETLS with TLS 1.3, and we have improvements to EAP AKA Prime are both working group documents. So does anybody have any other agenda items or anything else they want to discuss? All right. So first up, we have John Mattson. Do you want the control? Let me just get this.
Thank you. So this is the now working group adopted draft using ETLS with TLS 1.3. Take the next slide. It's me. So quite small changes since the non-working group adopted, some editorial changes, spell checking. There was one sentence that was rewritten on resumption based on a comment. I don't remember exactly who commented on that. And then I noticed that the new labels for the key derivation did not follow the recommendation of 5000 RFC 5705. So I added the exporter words. And what had happened since then is also that Joni Malinen has implemented the previous Mattsson draft, and he has some implementation comments and some suggestions, and that will be the main topic of this presentation. So Joni's first issue that he commented on when he implemented was that in TLS EAP, TLS with the TLS 102, you're quite sure the client knows what will come in the next step. In TLS 1.3, that's not the case anymore. If the EAP server is not supporting resumption, then after the client sends its TLS finished, the server will send EAP success. If the server is supporting resumption, after the finished, the EAP server will continue the EAP method and send the TLS new session ticket, which is used for resumption. And the EAP success comes in a later stage. So Joni's analysis of this is that the peer does not know whether the new session ticket will be delivered or not. And this leads to different handling. If you follow the RF 4137 state machine, the EAP state machine, in TLS previous versions, you can set it method state to done and decision uncon success. in TLS 103, UNI says that you need to set this to may count and decision con success. And UNI describes this as a bit inconvenient. And he asked if there's ways to avoid this uncertainty and also latency. We're introducing a new. The latency is with the new session ticket, you get latency equal to the old versions. So I would be great with feedback. Is this something we need to address? And also a comment from me on Jonas' comment is that new session ticket is not the only thing the TLS 103 server can send. Theoretically, it could send several new session tickets, and it can also send other post-handshake messages. How likely that is to happen or not, I don't know, but I think at least the TLS 103 draft should be clear on that, what the client can expect. And if you want to do the things that Joni suggests, then we would basically restrict TLS to a subset of TLS 1.3. If you have any comments, please.
Darshik Thakur, Cable Labs. So I think the point is well taken, right? But I guess we probably shouldn't try to completely restrict it, right? What we may probably be able to do is, or if possible, is somehow actually in EAP, right, in an EAP response, have a signal where the server can indicate that it may send other things so that the client can be aware of it. And that would be an EAP level thing rather than...
No, you're not changing EAP.
Okay.
Not happening.
Look, you've got some problems that are resulting from this. You have to be very, very clear because you can spoof EAP success. You have to be very, very clear about the state, the success state of ETLS at every turn, and allowing things to happen in different orders is going to be a problem for you. So, it's basically the reception of a properly encrypted message should probably take precedence over a success, but you don't want to be in a situation where basically a spoof success can actually change state. And like a spoof success can happen at any time, and the transition to a success state has to be driven by the TLS state machine. Can't be driven by spoofable messages. So I think you're potentially getting yourself into trouble here, if it's not clear, because in the original the TLS document is very, very clear when the state transitions.
So if I understand you correctly, you would like to have it either some additional information or restrict the messages that can be sent.
Yeah, I mean the clear thing in your mind is to understand at every point you must know whether you're in a continuing state or a successful state or a failed state. That has nothing to do with EAP. It has to do with your method. And if you're unsure, you cannot allow the success to determine that. Success may not be delivered. It could be spoofed, right? That's not the thing that determines whether the TLS exchange is successful or failed.
Would a reasonable response to this be that you're always going to want to spend, unfortunately it's you can use some additional latency, but would you always want to actually have the server send out one encrypted content message which says I'm finished? Because then you actually, then in the TLS machine, when you're done.
That's kind of how EAP TLS works today, is you're dependent on the finished message, and that makes the determination of the transition to success.
So would that be like, are you talking about a TLS message or an EAP message? Okay.
So what was to say? Wait until you get something encrypted with TLS, or yeah. But that would be then TLS. What, just encrypt nothing and send it in EAP request. That was the suggestion.
But the thing is, if this, so the finish message is supposed to indicate that after that the TLS will not send any more session tickets or any new messages. Is that what it's supposed to indicate? So the problem here is that at the TLS layer, it may send new session ticket messages after supposedly the TLS handshake is complete, right? And it doesn't know what to deal with it. Now, sending a finished message, is that an indication that from now onwards the TLS server should never send a new session? Because if it sends it, then you're still in the same problem.
I'm not suggesting that you send a TLS finish message. What I'm saying is the TLS server is going to send and encrypt a content message, a record, which says, you are now finished with all of the handshaking. Because then you know exactly when the server says you're done, and then you can make the transition. So that takes the place of the TLS finish message for EAP 1.2.
This is Hannes. So I think one of the differences to earlier or to other EAP methods is that initially you had this very clear distinction between the EAP method and then when it's finished versus in TLS 1.3 there are these post handshake authentication messages, and that doesn't exist in 1.2. So there's the question of what is actually finished really. Well, the new session ticket is still a handshake after all. So of course you can say maybe you definitely want that feature and use the session ticket functionality is a very useful feature after all. So you could actually cram it in earlier into the exchange and then only do the finish afterwards. You know what I mean? EAP finish afterwards, strictly speaking.
Darshak Thakur. So, but isn't the TLS server allowed to send the TLS session even afterwards? So I think, is there any criteria where you're restricting when the TLS server is allowed to send in TLS? It's allowed to send the new session ticket message, but in EAP you would have to restrict it somehow. I mean,
It's also allowed to send other things.
Yeah.
So, Eric Crisquella, so sorry, I'm not like super familiar with EMU. I'm a little familiar with TLS. So the situation is that you'd like to know that there won't be any more TLS messages after a certain point?
It's pointed out as an inconvenient thing by the implementer, Juni, and also Bernard seems to think that that's not good. You should know this date.
Right. I mean, so I'm surprised it's inconvenient actually, because my experience, TLS stacks just absorb this information as it comes in. I mean, if you continue to read application data messages, you'll just consume them. But it's hard not to. But in any case, I don't think there's a technical problem, obviously, with just profiling TLS to say don't do this. I mean, none of the post handshake messages are needed, as a practical matter.
Yeah. We probably need one new session day, but you're saying we don't need nothing more. It's not something expected to come in the future that. So if we restrict it, it will break in the future.
Yeah, I think it's probably true. I guess the one thing I would say is, again, just from a stack perspective, the way that most TLS stacks I'm familiar with work is that you'll, once the handshake is complete, you just basically, I mean, depending on the interface, you basically just read off the stack and you're like, give me more data. You pass in data and you're like, give me more data. And because you can't see from the content type what that data is, you don't know what's happening. And so the NST, I don't even know, I don't think NSS even has a callback for NST was delivered. And so if you want to have a state machine that like continues to read off the stack until like the NST is delivered, and then it's like now I'm done with that sort of context, that's like not super easy to do. So in that case, you might wish to have an application data message just to like speed that process along, right?
I think this is something we need to discuss more on the list in detail. With some suggestion from Uni was, can we inform the client somehow about whether the TLS server is intending to send more information? We have 5 reserved bit in the EAP TLS frames, which could potentially be used, but it's not secure, and I don't know how much, if the TLS server itself knows whether it's going to send information, and even if the TLS layer knows, I don't know if the EAP TLS layer would know. Yeah, I see people shaking their heads.
Yeah, if you use this and if it determines cryptographic state, you've just introduced a vulnerability. Don't do that.
Then next suggestion also from Uni, he did not like the additional latency for the sending the resumption new session ticket, and Uni wonders if the new session ticket could be sent in EAP success. He says this would remove uncertainty and latency, but would require an update of RFC 3748.
Yeah, if you start changing the EAP success measure, it's going to break NASs. You'll bust everything. Don't even go there.
Yeah, seems to be agreement in the room not to look into this. Then Uni's last comment is about the key derivation. So the key derivation in RFC 5216 looks like this. In the IETF 103 draft, this is changed to use the TLS exporter. And this recently, it got support from Alan on the list. The key derivation is one of the things that has previously caused interoperability problems for EAP-TLS. So this is something that really should be spent some thought on. Juni states that having a different key derivation for EAP-TLS is, with the same words as before, a bit inconvenient. And he asks if this is really necessary. This is basically what, if you would design it today, this is probably how you do. This is how quick does the export from TLS. So the previous, basically, the key material is, I think, compliant with the TLS exporter. The IV derivation is not. Then you basically needs to hack the TLS implementation some way, or at least you need to implement the TLS PRF yourself. The session ID, either you need to dig this out of TLS, or you need to look at the TLS messages. So yeah, is there, I don't know, how big inconvenient is it to have a new key derivation? What's the best trade-off here? No matter what, I think it's a need to, the draft should discuss what kind of interface we expect between TLS and EAP-TLS.
Mohit, so I guess Joni's concern is that ideally I should be able to update my OpenSSL from TLS 1.2 to TLS 1.3 and EAP magically uses 1.3. But in practice, it's not that easy to do. So then if you have to make the EAP layer aware of which TLS version you're using, a lot of these problems would be simplified. So then you use one or the other based on the TLS version that's configured.
Yeah, my understanding is that we will need to make the TLS client implementation aware of the version anyway because of the different message flows.
I think there's a problem with the session ID because if I recall correctly, and this is something you need to think about while you're doing this, a bunch of the TLS-based methods, I think, use a similar session ID with a different prefix, if I'm correct. Yeah. So, and I'm trying to remember why, I think it was, that tag was meant to differentiate like TLS from TTLS from PEEP.
It's the method ID.
Yeah, it's the method ID. Right. So eliminating that is, and I think the reason was that they wanted to have a unique space for the session ID within each method. So eliminating that is probably going to cause a problem because it'll bust the uniqueness of the session IDs.
Okay, so you said that should.
Yeah, you should have a prefix, I think, of the.
Okay, yeah, the prefix. Okay, yeah.
Yeah.
No matter what.
This is honest. I wonder how easy it is in general to get access to the random values in the different stacks. Did you look into that from
No,
a key derivation?
of course, either you have access to the source code or you can dig it out from the TLS packet looking at byte 6, but that also then you need to know that the randoms have a fixed length. If that changed in the future or something, then you might get into problems again. But this is something you can dig out from the package. What PRF you're using, you probably cannot.
Yeah, but, well, you may have, or most likely have, access to the source code for the EAP, for that specific EAP method, but the APIs typically don't make that information available, and you may actually want to reuse the implementation across multiple different layers. So, wondering whether that's such a great idea.
Do you mean that you are commenting the old thing, and you say that that's not a good?
Right. I think, Joe Salaway, I think where the way TLS stacks are moving is you would not necessarily have access to the master secret. I mean, that's why we have exporters. So I think moving forward, we would rather use exporters. I guess the one thing that I haven't really thought through, and I don't know if it makes a difference, is that, well, the key material is secret. I think the IV and the session ID are perhaps more publicly available values that we're deriving from the secret key material directly. I don't know if that matters. It really shouldn't, I think, but
it has changed a little bit. I think IV now typically are secret in some protocol, for example, TLS.
Yeah.
Okay.
Alan Decock from Jabber. My implementation already has the code to deal with different TLS versions, OpenSSL version etc. Adding one more isn't difficult.
Eric Scorla, yeah, please do not continue to do the thing that is 5216. It is not awesome. It's a bit inconvenient. I'm assuming that the session ID doesn't have any cryptographic properties because, like, that construction is obviously not tied tightly to the connection in any way. Anyway, so I think there's exporters are the way to do this now.
Yeah.
And so sorry about the inconvenience.
So then the agreement seems to be to use the TLS exporter, but add a prefix to the session ID. I think that's it. Wanted more feedback, reviews, of course, implementations, so that we can do an interop in the future.
Do we know who's working on implementation? It sounded like Alan was and Uni was. Do we know?
We have started a project, but we are currently implementing AKA things. So it's in the plan, but I don't have a time.
Okay. Thanks. All right. So we still have you up for large certificate chains in ETLS.
Yeah, so this is a very new draft submitted this week, but some of the information is taken from the TLS 103 draft. And this is one of the charter items. It was raised on the list during the charter discussion that this is a problem. I will describe soon why. And last meeting, it was agreed that it should be a separate draft. It should not be included in the EEP TLS 103 draft. So here's what the charter says. Basically what I said. And I assume this was this week, so I assume nobody has read it. But I will go through it, and I would like feedback if the working group thinks this is a good start. Is this the kind of information we want in this draft if we are doing a draft like that? Is something missing? So what's the problem to begin with? Certificate change can be quite large in size. Individual certificates can be large in the first place, and then you can have quite long certificate change. 2 to 6 certificate in the chain is not uncommon. This implies that ETLS need to be fragmented for transportation over the MTU, for example. This affects legacy, but it also causes a lot of connections to actually fail. And this is because quite many authenticators, I don't have any numbers on how many, but stated by Alan and other on the list, that a lot of implementation actually drops the EEP session if it hasn't finished after 40 to 50 packets. And if you have a quite large certificate chain, this is bound to happen. So even if the peer and server have credential to do mutual authentication, the session might fail because the authenticator shut it down. And you don't have any mechanism to easily recover from this. So the draft describes this, and then it discusses different ways that you can get your certificates and certificates change smaller. One solution is to use ECC cryptography. Then you get a little bit less public keys. You get smaller signatures. This can be used with all versions of TLS, and it's mandatory to. What? Okay, yeah. True. True. Yeah. That's true. It would be this if somebody used ED. Yeah. So another solution alternative is to omit certificates when that the other endpoint is known to possess. And when using TLS 102 or earlier, it's stated that only the self-signed certificate that specifies the root certificate authority may be omitted. In TLS 103, you can omit any certificate in the certificate chain that the other endpoint is known to possess. So this can make quite a large difference. This makes a small difference. New draft is solution is to compress the certificate chain, please.
Yeah, so because you talked about the chain, so maybe you don't want to have a PKI deployment with endlessly long sort of hierarchy. That would obviously make things easier as well. Furthermore, there's also this other work that we did specifically for dealing with reducing the transmission overhead, which is twofold: the cached info as well as the certificate URI, client certificate URI. I don't know if you have it on the next slide.
Yeah,
probably.
caching comes on the next one.
Okay. Sorry.
Yeah, but not using PKI or reduce the number of certificate authorities is, of course, a point that could be made in the draft.
Yeah, and that was actually the point that I also wanted to emphasize. So this document has some really good options in it, but it seems more of a protocol discussion. I think there's sort of a companion issue of operations, like how should you run your thing, and obvious advice, of course, is don't do that if it's problematic. But maybe that's too simplistic, and that there might be people in the room who have experience about systems where they've had to do this deeper hierarchies for some reason, and it'd be interesting to hear from them and see if that's the case, and if there's other technical or other issues that force that, and what we could do about that. Thank you.
Bernardo Boba, Microsoft. Yeah, EPTLS is very commonly deployed in large organizations, and the certificate authority structure parallels the organization structure. So you'll have a large company with multiple subsidiary companies with engineering organizations, blah blah blah, which is what yields these enormous chains. You're not going to reorganize the economy, basically. Give that advice. Reorganize the economy and make every organizational flat. Not going to happen. But things like not sending certs is a good idea.
Yeah. So third thing that it's mentioned in the draft is to compress the certificates. This is a working group draft in the TLS working group, and I think it's compressed quite well, but it's only possible for TLS 103. Yeah, but this draft is describing certificate in all versions. Yes. So this is another draft now. It's not yeah. That was what the working group wanted. It's a problem in. It's not likely that all will immediately change to TLS 103. So the fourth solution alternative, as Hannes mentioned, is the cache of the server certificate, or rather the server certificate chain. It's the whole certificate message that cached. So if you have a full successful TLS handshake, the client can cache the server certificate chain, and then the next time you connect to that server, you include this extension, and you have a fingerprint of the certificate chain.
Darshak Thakur, but isn't this result in sort of a chicken or an egg problem? If your first handshake itself doesn't succeed because of the problem.
Yeah, to go to Hannes's point, you have an opportunity here because of the benefits of 1.3 to actually fix a lot of things. Going back and telling people to change code, which is deployed in billions of endpoints, I don't think is that likely to succeed, and probably may not. I don't think necessarily it can do harm, but I would more focus on your opportunity here to tell, it is weird that this is a separate draft, because in some ways you have this opportunity with 1.3 to improve a lot of things. And I don't know if you're going to reference this draft from the 1.3 stuff and say that you should implement this as well. But it would be a really good idea to clean this up at the same time, because it's, if the point of 1.3 is to actually significantly shorten the handshake, and you've got these huge chains which generate 40 to 50, message exchanges, it's kind of pointless, right? Might as well do both.
So, can you scroll back, I think, to the, yeah, good, thanks. So I think, as I understand this charter item, it was primarily about guidance, which I think is very valuable. So I guess it seems to me that there are three settings, right? There are people who already have EMU deployed, and presumably they've banged whatever the certificates into a shape that will fit. There are people who would like to deploy EMU further, but aren't going to change code. And for those people, the guidance in these first two guidance bullet points are valuable guidance, right? Namely, you see, or and typically you do get to control the trust. Yeah, so often you just basically have to provide the certificates that you want handed out. So it's pretty straightforward to shorten the list. this next bullet point, and then, which of course are only possible in 3, and then on the next slide, cached info, are good techniques, but they require changing code. And those people, I think, might as well just like hoist over to 1.3, right? I mean, these guys have to, obviously. So I think what I would try to focus on, if it were me, would be the techniques which require code changes, somehow are intermeshed with the 1.3 stuff, and the techniques which are just like, here are some good practices you might want to use. Those like seem totally in scope and really useful. So that may be. I'm not sure how to structure the documents, but that might be a useful way to think about it.
Mm-hmm. And the last thing here, that if you use this, as pointed out already, you need to wait for a full handshake. Otherwise, and so this is a chicken and egg problem. It doesn't help. It's stated so in the draft right now, but it's stated that it could lead to man-in-the-middle problems. I cannot see that directly. So would there be a possibility to use this even from a failed handshake when the authenticator cut it down?
So I think it's not that. So at least from how I understood the situation with these longer certificate chains and the success rate is that, yes, sometimes it doesn't work. Sometimes the exchange doesn't complete, and there may be retransmissions and all sorts of hassle. But we are not talking about like never works. It's just crappy experience. But once you got through the exchange, because otherwise you cannot use the whole thing to begin with. So once you get through the exchange, you cache them, and presumably, specifically, so this is not the web environment where you randomly talk to some server on the internet, but instead, once you manage to get that exchange, which is most likely when you are in your enterprise environment where the hops are short, where you don't have to deal with all sorts of annoyances. But then when you go off and travel somewhere where you suddenly have to roam around and there's a complicated multi-hop AAA infrastructure, then that's where things break. And that's the time when you actually should have the stuff cached already.
Dr. Tagore, I think that's probably a fair point. And I think from the experiments or tests that were done the last interop, I think it was also the fact that a lot of this happens also based on the size of the EAP packet, right? So sometimes you actually have shorter sized EAP packets, and that's where this is more likely to happen. So, but maybe we can probably give that guidance. If you want to give this guidance, as Hannes said, right, you can probably include that also in the guidance.
So, Mohit, as Darshak mentioned at the last hackathon, we were running some tests, and this char item was brought in by others in the group. So many access point are actually, I have tested with 2, and one was enterprise access point. They, as a denial of service protection, drop if the EAP session doesn't complete within 40 round trips. So if it doesn't complete between 40 round trips, you will never get a EAP success. And then even if you have the right certs on both the ends, you would never be able to use this cache information exchange. So that's what we experienced from the hackathon. We don't have deployment experience. This is what Alan and some others on the list brought in.
This is Hannes again. I think then the recommendation should be, in addition to the stuff that you said earlier, is there may be also a need to change your access points, to reconfigure your access points, because you are essentially, you made deployment considerations like deep certificate hierarchy, RSA keys with a key size that would resist both quantum crypto sort of issues, and then you expect it to work smoothly in your environment. So there's just, you cannot have all the things that you want. It's not Christmas, right?
Would there be a security problem to cache certificate change from a non-successful handshake? No. Personal quick analysis should that it would be okay, but it definitely need more analysis, and doing that would go against the certificate chain caching RFC.
Yeah, exactly. So I'm assuming that in this environment, this is like because this is EAP, I don't have any other network connectivity other than this thing right now. So like we can't just like We can't just like outport them to some web server somewhere. That's what I figured. Okay. I don't know. I'm like pretty, I mean, maybe you could do, God, it's like, I mean, I take your point that like, it's like no obvious reason why this wouldn't be okay, but like, it's like not how we roll. And like someone would really need to put some analysis about why it was okay.
It depends on if some implementer wants to do this, then we could analyze it. Otherwise, not. And that's all. Like feedback on this draft. If you have any recommendation, anybody has any experiences about what was mentioned was that we should write a little bit about how organizational structure affects it, but it's not like anybody is going to change the organizational structure to solve this problem.
Hi, Sean Turner. PKI provides many foot guns. We can maybe provide some examples for ways not to shoot yourself. Like in the draft, you have like long names. Like don't put 150 subject alternative names in your certs.
Yeah.
You know, all kinds of things like that. Pick shorter OIDs if you can get away with it. Don't put your CPS URI in there or a bunch of text files and crap that a lot of people do. Just don't do that. And so for an EAP context, if you can get away with avoiding all of those, the cat pictures and I mean, maybe your logo can be omitted from this particular certificate. Like you
only EMU pictures.
Exactly right. I can volunteer to help you with a little bit of some of
that
this.
would be great. Thanks,
just so that we can do things better. Thanks.
Yeah.
Okay, thanks. Okay, Yari, you're up.
Okay, good morning. So talking about two drafts today. The first one is the EAP aka Prime 5448 update. And so for background, if people have forgotten, so EAP aka was defined some years ago in the 2000 something, and we also later revised it slightly. The revision had to do with ability to bind authentication context to the actual authentication process. And these RFCs have been fairly widely implemented, probably in the billions, and somewhat widely used, not in the billions, maybe more in the millions or tens of millions range. And the context for this work previously was that you could use SIM card infrastructure while you're doing wireless LAN access. And when you're doing the mobile network access, then you wouldn't use EAP directly. But 5G changes this because they allow both the old native approach to authentication as well as EAP and different methods, with the EAP aka Prime being the default method in 5G. Okay. And of course, when it's an old spec, maybe some craft has accumulated over the years, and also in a new context, maybe there's some things that we actually have to specify. So there's some number of bugs, some missed items that should have been in the original RFCs, maybe some additions in the security consideration section, things that we learned, and then we need to specify the behavior for 5G. And for 5G, there's basically two issues here. One is that you had this, you previously had this network name binding, and there was a table in a 3GPP specification that specified, like, these are some, the structure of different network names begins with the string followed by colon, and then possibly some other parameters. And that table has been updated, and so now we're pointing to the new table. So that's relatively easy, but still important, because otherwise the authentication doesn't work. The other important piece is that there's some changes to how 5G deals with identifiers and actually affects here. I'll talk about that in a sec. We also included the definition of exported parameters in a complete fashion that we had missed in the original RFCs. The time that we were writing the original RFCs, there was some other RFC 5247 that was progressing in parallel, and that got missed. And then we updated the references. So the identifier thing. So previously this was clear for all cases that existed. Use essentially then the identifier that was sent, like whether no matter where it was sent, whether it was sent an EAP identity request response pair or somewhere else, layer 2, use that identity. And it's important that both sides actually agree on what identity is used, because the identity is directly used as input in the KDF. So if you get it wrong, keystone match, which is bad. And fifth, with 5G, there's a couple of things that change, or primarily one thing, but the context is that typically you would run EAP inside the authentication process or the network attachment process in 5G. And it doesn't use EAP identity request and response. That the identity is communicated at layer 2. And secondly, in 5G, there's two distinct identifiers for subscribers. There's one, the permanent one, subscriber permanent identifier, or SUPI. And this is, I'm saying here, it's never sent over the wire. There's some exceptions where it actually appears to be sent, like an emergency call and no authentication available or something like that. But in normal circumstances, that is never sent to hide the permanent identity from whoever might be listening. And then there's a temporary privacy-friendly identifier, subscriber concealed identifier. And the 5G network attachment process, it's complicated protocol exchange where some of this information is conveyed, and the question now is, if we do EAP right after, which of the possible identifiers we should be referring to. And while one might actually have different opinions about this, what the answer should be, what I'm trying to do with this draft is that the 3GPP is progressing their specifications, and they have said some things, made some decisions, and I'm trying to align the RFC updates to those decisions. And their decision in the SA3 group, which is the security architecture group there, was to use the permanent identifier as the basis for key generation. So this is what the draft says. So and we can detect when we're doing the 5G thing, because again, the authentication context is communicated. So we're gonna tell the other party that now we're doing 5G, and that's has a particular string associated with that in the network name field. So we can do the switch. It's not the cleanest way to do things, personal opinion, but trying to align people on the same approach as opposed to inventing something else. Versions, you've seen two versions fly by. The version 00 was simply the same as the previous one, but that's a working group document. And then 01, which had a bunch of updates. We realized that we need to update the relationship to RFC 4187 as well. We clarified language, or the exact word that we used to say about what we're doing with 5448. We updated the references as mentioned. We specified the network name and the identifier construction, which is the technical content of this thing. Next steps and what remains. So at the moment, I think this is in sync with what 3GPP is doing. They haven't actually replaced their text with a pointer to this draft, and indeed the working group version of the draft is fairly recent. but I think they could do that, and I have already requested that to happen. There may be some things that we still need to work on. I heard from John some comments around the security consideration section. Maybe you want to come to the mic and explain.
Yeah, John Mattsson, Ericsson. I reviewed this quite thoroughly, and I think it's quite obviously it should not be any changes to the old technical section. So I think this is very much ready. I will do a second review and try to review the alignment with the 3GPP specification that I have not done. Can promise to do that in coming months. What struck me when I was reading the security consideration is that the demands on security considerations concerning privacy and pervasive monitoring is much higher now than when 5448 was written. So I would suggest that the security consideration is that text on privacy and pervasive monitoring is added to the security consideration. For example, for privacy, what happens if the encrypted SUKI is not used? The hope from the industry is that it will basically be used everywhere, but it's up to the operator to deploy the public keys on the SIM card. So I think the draft should go through the threats with IMSI catchers and so on if the encrypted SUKI is not used. And also I think it should discuss what happens with when the long-term keys on the SIM card is somebody gets holds on them and use them for example, for passive pervasive monitoring can also be used for attacks on specific users. And this is something that has allegedly been happening in reality in quite large scale.
Yeah, thank you for the review and the comments. I certainly agree that those are things that need to be added to the security considerations piece, and the SUPI thing is a new technology development that affects this, so it clearly needs discussion. And of course, in the meantime, we've learned about this massive key leakage attacks going on, so that definitely needs to be explained. Anything else, either in security considerations or otherwise? This would be a really good moment to add stuff that we've not realized so far. So while nobody's coming to the mic yet, I'll also say that this is sort of designed to be part of the first release of 5G. So and I've taken a sort of a rather relaxed approach to exactly what, where the references go and such, or when they reference this. But 3GPP traditionally has had an ability to replace their temporary thing in a TS with a reference to RFC when that RFC comes out. But I do think that this should go forward as soon as possible. And so I would actually suggest that we're close to working group last call, and we should initiate that after the security considerations update and then get it done.
So Shantar, to that particular point about timing, like fast is like 6 months, a year, because usually like it takes 3 years to get anything done in the IETF. So you're hoping.
I don't agree. But
I don't have as much pixie dust as you've had in the past.
Yeah, I mean the question is, I mean, it probably takes a long time to do completely new things, right? And so this is abyss, and
right. So it ought to go quicker. Okay.
Yeah, and I don't know, but we should definitely try.
I want to help. So if there's anything I can do, let me know. We'll
review it now, and then we'll update it today. Oh, yeah,
So,
tomorrow is still okay.
I don't see any reason why we couldn't, if when we get an updated security consideration section, and and if there are any other remaining comments, when we get those addressed, we can last call it. So I mean, and I guess my question is, what's the timeline? I guess there's a little bit of risk potential risk if 3GPP decides, okay, we're going to make changes, then we have to go back and change this. Or how stable are they? Or
I think they are ahead of us, and we're trying to match what they have. So I think the risk of that is less than the risk of them feeling that their thing is too ready to be even make a reference to a new RFC.
Yeah.
But even that wouldn't be the end of the world, because we can always make that in the next release. But I would really like this to get to this one reference for this.
yeah,
And one thing that I forgot to say is that we are running a project to implement some of this, and then there was some discussion on the list, and it seems like we were not the only ones, so we don't have something yet where we can actually test with others, but we will soon. So we looking forward to that.
if we can, both for the EAP TLS and for the EAP AKA Prime, if we can, kind of identify implementations, that would be good.
Yep, I think that's it, and then we know what to do. So thank you. And was I next also?
Yes.
Okay, so this is a more of a new thing. This is not for the current release of 5G also, and this is more of a, let's say, my personal problem. Some organizations attacked infrastructure that hold keys for my protocol, and as a result, my protocol is broken, obviously, because if the keys are broken, the protocol is suffering, and I want to do something about that, like even from a sort of personal perspective. And the background for this, of course, is maybe everybody already knows this, but there's been reported attacks on like the manufacturers of SIM cards, so you get like all the secrets of everybody's cards, and which is really bad. However, perfect forward secrecy would help defend against it. It's not a end all concerns solution, but it does make this less of an issue, because against passive attackers, your actual own communications on your phone will still be secure, and then you're forcing active attacks if they actually want to use the acquired shared secret information that they stole. So can we do something? So I won't go into the details of the protocol. I'll probably have already read the draft, but it's essentially a backwards compatible extension to that Diffie-Hellman exchange to EAP AKA in a particular way. So there's indeed you can, we're not adding any round trips, and if the other side doesn't recognize this, then you can actually just keep going and do the usual thing. And the resulting keys from when you have this feature enabled on both sides, then the resulting keys will provide PFS. And the main exchange is that it's just embedded as part of the EAP AKA Prime, and you just add some attributes, one attribute for signaling that you want to do a particular new way of key generation, and then you carry the public keys for both sides, and then you keep going and generate the keys. There's a couple more details that was not shown in this previous picture. In the draft, it explains like how it's possible to do this without touching the SIM card. So it will be the phone, not the SIM card, that's running the Diffie-Hellman piece. And also on the other side, it's the EAP authentication server, not the HSS or the one that stores the keys, which helps add this feature, because you don't have to change everybody's SIM cards and so on, which is good. And of course, if you do this on EAP level, so anything that is based off EAP keys will benefit from the higher quality key material produced by keys that also include the Diffie-Hellman parameters. And so you could potentially imagine using this both for whatever is on the access link security, and if there's anything that you need to discuss with the whole network in some fashion based on the keys provided by this, then you can do that. a little bit of motivation still. So the first motivation, of course, is that since I feel that my protocol has some issues, I'd like to fix it. We also have RFC7258, obviously, that seem to be demanding that we look at pervasive monitoring attacks, and this is certainly one of them, and take them into account one way or the other. Modern cryptographic protocols generally try to do PFS, so this seems like bringing the protocol to that level. And also, there is no technical work yet on this, but in 3GPP, in their next release, in phase 2 of 5G, they have agreed that they will look at providing perfect forward secrecy in some fashion, and this would be obviously one way of doing it. There might be others. And I think that the timeline for that is 2019. And the question is that if we were to provide a specification now, or at least make it go forward enough that it can be used by others, then that might actually have an impact. We have an ongoing implementation effort of this as well as the previous presentation. And would be eager to get this in the working group. Hannes.
Jari, I was when you showed the exchange and you added the Diffie-Hellman exchange. So typically, whenever there was public key operations, there was always the concern that there would be some denial of service attack. You can basically flood the server with requests and make him do a lot of work without the client actually contributing anything to this. Do you see that as a non-issue here? Because it, like, you know what I mean?
Yes, and that's a really good question, and one that hasn't perhaps been discussed enough in the draft. But I think the situation is that in this particular case, so it's kind of initiated from the network side, and you, like, in order for this whole thing to begin to at all, you have to be a phone that connects to the network and starts the connection process involving multiple exchanges with the network. And then you get the first request for the authentication from the network, including the Diffie-Hellman thing. So you as UE cannot DOS the network side or the server. So that's point one. And secondly, for somebody else to DOS the UE, of course, the damage on one UE may be smaller than the whole network, but also, you know, they would have to, I mean, at that point, you don't have security on yet, obviously, because you're still authenticating and generating keys. So you can, in theory, get to that process by somebody monitoring and doing an active attack on the radio. But that means active attack on a radio on a particular point with relatively small cell size. So it's doable, but the damage is maybe constrained.
Mm-hmm. But we've seen that these EAP methods are also not just used for the classical network access authentication, but also then for cases where you have VPN access and these type of things where it's actually initiated by the client. Also, in some of the wireless LAN deployments, it's quite possible that the wireless...
Before you go there, so you said that it's initiated by the client, but like this protocol always runs, the server side of EAP initiates this particular enhanced extension or enhanced exchange. And so do you have cases where, like all the cases that I'm aware of, where you use like VPN access or whatever, it's still like the client initiates the fact that I'm trying to connect to this VPN, but it's the VPN box that tells me, okay, now please authenticate.
So you think it's non-applicable?
Yeah, I mean, I'm not saying that there wouldn't be another case, but that it's still the same issue.
John Mattsson Ericsson, just additional comment about this with asymmetrical crypto. EAP, aka in 5G always, right now with encrypted SUKI, the server will always use asymmetrical crypto to unencrypt the identity. If you don't know how SUKI works, it works extremely similar to the encrypted SNI proposal in the TLS working group, but the client gets the public keys from the SIM card instead of DNS in the SNI case. So I think adding this would be 2 asymmetrical operations on the server instead of 1, but it's not the order of magnitude higher.
Yeah, and it seems like the direction actually on this earlier exchange, which is not part of EAP, but part of the network attachment in 5G, is actually reversed from what we just discussed. The problem in EAP may be a little bit less than in that, but they feel like they have that under control. Whether that's true remains to be seen, but that's what the spec says. Russ.
Hi, Russ Housley. Could you back up to the one that shows the, there you go. So without this additional Diffie-Hellman, where is the authentication that would be available for AKA prime? And can you validate that before doing the additional Diffie-Hellman to eliminate the, if you're being spoofed, then that part will fail, so I don't even do the extra work to get to the PFS. If you can strictly order that, it would eliminate the thing that Hamas raised.
That's a good point, and I'm not sure I remember exactly what we do in that respect today, but that seems doable, and the design is such because we want to have this backwards compatibility, so we actually send everything that is needed for this regular authentication. So it would seem that that's if it's not done, then it seems doable.
I mean, you can send it all. It's the order you process it in that eliminates the
yeah, obviously, yes. Thank you.
There's one question. Max Pala, Cable Labs. Is this the public key that is used for the exchange the same as the one that encrypts the SUCHI? Or not? Or is it a temporary one?
So we have our own exchange and say nothing about what the public key. I mean, we just like this is our protocol and use public keys from both sides. I see where you're going, but we haven't said anything about that at the moment.
Okay, thank you.
Russ Housley, I assumed that you were using ephemeral Diffie-Hellman here.
Yes, actually, I am. So yeah. So we
so that does say something about what you just asked.
That's right. Sorry.
John Mattsson, Ericsson, as I already commented on my security consideration before, I think this is a real world problem. This is something that IETF best current practices says we should do, and here we have a protocol that has been in the past been is suspected to pervasive monitoring and allegedly have been targeted in massive pervasive monitoring. So I think this is definitely a direction which the working group should go, and I'm very supporting working group adoption of this.
How many folks have read the draft? Okay, not too many. Is there, how many folks think this would be a good problem to work on? Raise your hand. Is there anybody who's against working on this? Okay, so I think we'll do a call for adoption on the list since it's in our charter and it seems like a reasonable way forward. Probably there'll be some discussion of the details. But
yeah, clearly, and I'll work on that. Thank you.
So now I think Owen's going to give us a little bit of an update on what they've been looking at with respect to Brewski.
Hey guys, Owen Friel. So what we've been looking at is how to run Brewski, Anima Brewski bootstrapping remote key infrastructure inside an EAP tunnel. There's a related draft that we covered in the Anima session on Wednesday, which is running Brewski over Wi-Fi networks. And it describes a larger problem space. And one of the solutions to some of the problems is to run Brewski inside a EAP tunnel. So what are the problems we're trying to solve? And some of these problems are generic to wired networks as well. But what are the problems we're trying to solve? Like, what Wi-Fi networks support Brewski? How do we avoid a device onboarding against the wrong Wi-Fi network? What credentials does the device use before and after it's completed the Brewski flow for authentication against the network? And some of the problems that are probably more specific to TEAP Brewski is how long does it take and what signaling is required for the device to determine that the network is untrusted? How complicated is the device state machine when it's switching between candidate networks? And how complicated is the device state machine when it's onboarding against a correct target network? So the Brewski over 802.11 outlines some possible solutions. It doesn't make any final recommendations. What this draft, the Brewski over TEAP, it describes some possible solutions to some of the problems. So just a refresher for those who aren't too familiar with Anima Brewski, when you first time power up a device, when you first time power up a pledge, it trusts nothing apart from maybe a manufacturer embedded root anchor. You deploy the device in your local network, it's going to discover some kind of registrar. It doesn't trust a registrar. You can think of the registrar as akin to a smart middle box. So what the registrar does is proxy voucher requests between the pledge and the trusted manufacturer server. The manufacturer server will return a signed JSON blob instructing the device to trust the registrar. The device now trusts the registrar and can continue to bootstrap. So this is what we could do for device bootstrap with the existing mechanisms we have today. So device boots up, it sees multiple SSIDs, it does an 802.11 connect, the network is enforcing 802.1x, it does an authentication using its IDEV ID, it does DHCP, gets an IP, does DNS discovery, connects to the registrar and issues a voucher request. The voucher request goes all the way up to the massa. The massa will respond saying, don't trust this network. Typically what happens with most devices, certainly any device I'm familiar with, after the device is IP'd, if it needs to re-IP and connect to a different network, it needs to reboot. So in step 4 of the device reboot, it'll repeat that process at the next candidate network. This time, the massa will return a signed voucher to the device saying, yes, trust this network. But the device is already IP'd, the device has done DNS. What will typically happen, because the device now has been credentialed with a different identity search. It started off with its IDEV ID, it now is an LDEV ID, it's been re-credentialed, it needs access to a different network segment, it's probably going to have to reboot to get a new IP to put it on the correct network segment of the target network. So that's happened in step 8, the device reboots, it does 802.11 again, it does 802.1x using its LDEV ID, it now can connect to the correct target network and finally access services. So that's a really, really complicated state machine. This is what we'd like to do. We'd like to run that Brewski voucher request, voucher response, trust establishment flow inside in the EAP tunnel. But what that means is that when the device finishes its 802.1x authentication, the device knows whether or not it should connect to that network or not. If the massa instructs the device not to connect to the network, the device will fail authentication prior to IPing. It will fail authentication at layer 2. That makes the state machine on the device far simpler. It hasn't got an IP address at this stage. It can now go on to the next target network and redo 802.1x authentication. This time, when the massa instructs the device to trust the network, it can continue to IP, DNS, service discovery, and access services. So if you compare this state machine of what we can do today versus this state machine, if we can do Brewski establishment at layer 2 inside EAP, it's far, far simpler from a device perspective. So this is just a little bit more detail on Anima Brewski. We described it a couple of slides ago, but there's 5 key steps. The device establishes a provisional TNS connection to the registrar. It doesn't trust it. The device exchanges vouchers via the registrar with the massa. The device then verifies the TLS connection with the registrar. It downloads trust anchors and it optionally enrolls to get a LDEV ID. And EAP-TEAP is a really, really good fit for this. If you look at these 5 steps, TEAP supports server and authenticated provisioning. TEAP supports definition of new TLVs for transporting application-specific payloads such as voucher request, voucher responses. EAP supports final verification of the TLS connection after phase 2 completes. TEEP has already TLV definitions for downloading trusted route anchors. TEEP already has TLV definitions defined for doing search enrollment. So all of the problems we want to solve for Brewski, TEEP has solutions for all of them. This is the EAP Brewski architecture. This is what it would look like. Your device connects to the authenticator, which connects to the TEEP server. The TEEP server connects to a Brewski register on its back end, and the Brewski register in turn will talk to a MASA or a CA. The TEEP server and the Brewski register could be co-located. The Brewski register and the CA could be co-located. That's deployment specific and architecture specific. And this is the high level EAP Brewski flow. Like this flow is taken from the draft. There's multiple other flows in the draft as well. There's a few new TEEP TLVs defined, one for voucher request, voucher response, voucher status, enrollment status, CSR attributes. The Brewski TLVs must be exchanged prior to crypto binding. We're suggesting that we do Brewski as new TLVs, not as an EAP method. So what that means is there's no need for channel binding. There's not an inner TEEP method. And this is the summary. Running Brewski as part of IETF102-EMU-20180720-0930 really simplifies the device onboarding state machine. EAP is a really good fit for Brewski. Defining new TEEP TLVs seems like a better fit than defining a new EAP method. And we're looking for interest feedback, and we would like to get this adopted. And that is the last slide.
Question from Jabber, Alan Dicock. So who implements TEEP? IRC, it's almost no one. That does make this more difficult. And the other question is, if the MASA doesn't trust network, why is it doing an 802.1x exchange with it? Perhaps this is more not the right network than not trusted, though I'm not familiar with Brewski.
Well, even in a wired use case, well, I'll take the second question first. And for first question, I'll defer to Nancy, who's in the room, and Nancy wrote TEEP, and Nancy's in the correct business unit to ask when Cisco is going to be building TEEP support. Yeah. So the second question first is, even on a wired network, the pledge doesn't know whether to complete IETF1X or not. So it's going to do the client to know, it's going to get back a server certificate. It doesn't know whether to trust it or not. So it has to do the massive flow first to decide whether it needs to trust the 802.1x server. It's going to get a server certificate back. It doesn't know whether to trust it, and that's the same problem regardless of whether you're in wired or Wi-Fi.
Yeah, I mean, more directly, if I can elaborate on that, the MASA wouldn't be in the .1x path anyway, because it's way deeper in the infrastructure. So the .1x is really to establish the communication on the edge. So that answers the second question. As to the first one, it is correct. TEEP right now is not used predominantly. The issue is, and I know from the industry side, that EAP Fast is predominantly used, but it's not standard. So we could have chosen to do all of these extensions in EAP Fast, but we'd rather go towards a standards track piece of work. And so if you look at the difference between EAP Fast and TEEP, they pretty much are the same state machine. Some of the crypto and the PRFs have changed. So our preference is to go towards a standard route so that we can get traction. So.
Okay, you will stay. Okay, Shubir Das. Can you go to slide number 6?
Which is that this one?
No, go back. Early on. Go back. Yeah, this one. So, how it is different today if you have a AAA infrastructure? It will also do the same way, right? With the, say, for example, with the radius, it will fail if the authentication.
This is today. This is what you do today. You have to complete IETF1X first, get your IP address, then do application error discovery for registrar, then do the Brewski flow. Then if that fails...
No, not Brewski. I'm just talking about just simply with AAA today, say radius. So it is done exactly this way, that if it is not correct network, then it will fail today with radius, right? So with the backend AAA, with the radius infrastructure, it is done exactly the same way.
But
what this is...
with the Brewski flow, the device is relying... Well, first you're making the assumption that the network is well behaved and the network will reject device it doesn't own. And what the Brisky flow adds is the massa is going to vouch for the network you're trying to connect to. So the device does.
Yes, I understand that point. What I'm saying is that if AAA infrastructure is there, this is not adding anything else. Of course, I understand the Brisky has a different purpose and different, thing, right? But the problem in the previous slide, what you mentioned, and this second slide, which motivates, it is my understanding it is solved today with the AAA backend radius. Exactly, it will do the same thing because I will not get IP address with 1x with EOL. It will happen, and then if it fails, I'll not get IP address. I'll move on.
So again, you're making the assumption that the network is well behaved and it's going to reject.
No, I'm not assuming that. You said that IP address. I go to a network. I go to AAA exchange. It fails. I move on. I'll not get IP address. It will go to 1x unauthenticated port. If it will fail, I'll move on to another one. So I'm not wasting anything. I understand the purpose of Brisky and Massa is different, right? And you're trying to bring it here, but exactly this procedure happened today with AAA.
But with the AAA, but again, the network, the AAA can accept the device to the network. So the AAA can accept the device to network, and 802.1x authentication can succeed. And then the device will connect to the registrar, and then connect to the massa. And the massa will, after 802.1x authentication has succeeded, the massa will reject that network.
I think the main issue, this is Hannes, I think the big issue here is that under the cover, Brisky came up with a new network attachment procedure, network access authentication. Let me speak. Because I think that's the thing that you realize, and it's also a little bit hidden in the first slide that you mentioned when it says the device doesn't have anything except. That's also what is in the document, the Brisky document. It makes this sort of weird, wishy-washy claims about what it tries to solve and what it doesn't do. And the reason why I very much understand your question, because I actually ran into that myself. Why can't you just use the regular AAA procedures here, is because it's trying to change the way how the AAA works in the backend by basically not running it to the manufacturer, because the claim is that you don't actually need to talk to the manufacturer for privacy reasons, it's claimed. But then you need to set up this alternative infrastructure with the massa, because now you have the problem that the device cannot authenticate to the local network because it doesn't have the trust anchors. And now you need to push these sort of things around. And I think that in the IETF so far, because very few people pay attention to Anima, we have actually bought into that concept that this is a good idea, what you are trying to set up, this alternative approach of doing network access authentication. I think that's my problem when I read the specification of the Brisky specification.
So what you're really saying is you want your device to do trust and first use. I'll trust the first network I connect to, I'll just trust it. If the AAA,
no,
that's really what you're saying.
No,
if the AAA lets me in, I don't need any pre-provisioned trust anchors.
And that's
the problem Brisky's trying to solve.
What I would really like to have is an honest conversation about what we are trying to accomplish with this alternative network access authentication infrastructure. Because when I read Brisky, I see problems being stated, and then later in the document, I see the same problems being resolved using things that were actually solutions. What you complained about the problems. You complained that it's difficult to manufacture, to put manufacturer certificates on a device. Later, you make use of them. You claim about the privacy implications of running the exchange to the manufacturer AAA server. Later, you actually, for security reasons, you still have to interact with the manufacturer. And so, like, the whole thing is just marketing nonsense.
So one thing I just, with this again, I just add that, say, for example, I deploy AAA infrastructure, right? And then, do I need this, right? That is one thing, right? Because my current understanding that if I have a AAA infrastructure, the motivation what you said that it is actually doing the same thing. So it will be good to have maybe a section that, okay, if I have a AAA infrastructure, right, what additional benefit this will add to the, with the system. that will be actually a good thing to
Well,
understand.
what you're asking for is what's the benefit of Brewski in the first place, not what's the benefit of doing Brewski inside an EAP.
No, in this particular environment, because in this particular example, what you said that, oh, I don't trust, I don't know what the network is, right? And I just try to connect, and this gives the benefit that, okay, I know that this is a trusted network. So point I'm making is that with the backend AAA infrastructure, exactly that is what happens today. I try to connect, I fail if authentication, and then I move on because I'm not given any IP address or anything or any resource to the network. And the one I succeed, I connect, right?
But
Brewski is giving you the opportunity to connect to the network. You don't get that with normal.
Sorry, Brian White. I'm just trying to clarify. The Brewski is actually in this step allowing you to authenticate, get to the point where you could authenticate the network instead of moving on. You could move on all day to all the networks you want, and nobody will authenticate you with a normal backend today if they haven't provisioned you with any credentials. This is trying to get you to the point of provisioning you credentials because with that initial trust.
Okay. So Brian, then maybe I misunderstood. Say, for example, if network B is not trusted, the MASA says that, okay, you don't trust this network. That will fail, right?
So that is kind of a little weirdness here in the slide. Okay. Normally, it is going to always be the enterprise's decision whether to trust the network. MASA is helping it determine. There are cases though where the enterprise might use the MASA for a little more information about whether they should trust this. But normally, the MASA is used to give you information about the device, and then the enterprise is going to decide whether it wants to trust this device or not.
Okay. Maybe I just need to read a little bit more because the motivation here is basically I didn't understand. The motivation that this network is not trusted and it's helping me to trust this network. But if the network BA is not trusted, even the MASA cannot help, right?
But it's more than just the tested, right? So the other piece, so to add on to Brian on
Make sure you're using the mic.
Okay, sorry, I'm short. Okay, vertically challenged. So the other part in Brewski is, and part of the voucher request is to help the endpoint know, and that's why I say it's beyond tested, that network infrastructure is to be trusted. That's what the voucher request is for. And that's the Brewski aspect, right? And so you talk about the AAA infrastructure. The difference here is that AAA infrastructure doesn't have the right identity, which is what Brewski is trying to help. It's trying to help provision the right identity so that eventually not only can the endpoint trust that network, but that it also has that credential.
Yeah.
Okay.
Yeah. So one last point. I'll then say, Nancy, you know that there are, like, for example, there are other ways to know that, right? For example, the network discovery with 11U, right? So there is other point to know that if the network is trusted or not.
But that's the chicken and egg. That's the chicken and egg problem that we are attempting to solve with Brewski, right? And so 11U is the other aspect of how we do the signaling. And so that's the thing that Owen presented at Anima. There are different ways in which we could use DPP, we could use 11U, we could use extensions in the association request in .11. That's the separate piece. This is the piece of, do we want to have multiple conversations, right? Because today Brewski is at a higher layer, or we could actually embed it, especially on the Wi-Fi, and just have all of that signaling happen while you're still in that .1x channel. That's what we're proposing. Sorry, Owen.
Hi, Max Para, Cable Labs. So I think that this conversation was very useful in the sense that it clarifies that this is a provisioning mechanism, is not the authentication. I mean, that comes as a good benefit afterwards, but it's a provisioning mechanism, and totally support that. TIP already supports EST. One of the things, and maybe something that, as a group, we might consider to maybe have a generic method for provisioning through EAP, which can plug in different methods. Brewski could be one, EST could be another, and maybe there might be some even easier provisioning ways. that could be plugged into a generic EAP method. This is something that might be a different discussion. One of the considerations that I wanted to bring out about what you said, implementing with TLVs instead of its own method, it seems like it's an easier approach, right, to do TLVs because you take what exists already and just define new TLVs. However, this brings up the problem of TEEP is not really implemented today, and you could potentially do another method and combine that with any existing tunneling methods, so that the security properties could be provided through other already deployed methods, and you can use an inner method. Maybe this could help the deployment. I'm not sure about that, but especially because you don't have to implement the whole TEEP, but only the provisioning part, and that could be easier in existing implementations.
Yeah, we had considered a new EAP method, and we had assessed the pros and cons of a new EAP method, and we decided that TLVs are probably simpler, working on the assumption that we're going to ship TEEP pretty quickly.
Right. So if I can elaborate on that, and we were mentioning while we were on the queue. So as Owen said, we debated it could absolutely be its own EAP method, but again, it's that chicken and egg problem. So by establishing that TLS tunnel, we've now taken care of effectively now, with previous conversations of whether we support establishing a secure tunnel. So I think the issue and why we went this route, and you can blame me because it makes the security considerations and potentially the privacy considerations, if it were to be a standalone method, would be more complex, and there would be a lot of requirements of how that EAP method would have to run.
I totally understand, Max Pala, Cable Labs, totally understand your point. I'm just trying to say maybe there's an opportunity here to have a more generic approach to provisioning than just extending TLVs in one existing method. That's what I'm saying.
Sure.
Yeah. Sorry, I'm just helping Owen since I'm one of the authors, right? So that's certainly fine. And I would say if that's the way the group would prefer for us to go, we can update the draft to go that route, right? We just, again, we took the path because the security is improved when you're running it under a protected tunnel. Yeah.
Okay, there are quite a few questions from Jabber. First one is from Henry Hertz. Maybe not possible to improve, but it seems like there are steps where the device is trusting things it doesn't yet know it can or should trust. How does it work? As in, how does it properly fail if network A is evil? So this is the first question from Henry Hertz. Another one is from Alan Decock. If 802.1x succeeds, then the network is trusted. If the massa later rejects the network, it means that the network is known and trusted, but not the right network. If network 1 is not trusted, why does 802.1x succeed? Why would device trust Brodsky data sent over an untrusted 802.1x configuration? Then we have another question from Henry Hertz. Suppose network A and massa that network A connects the device to both are evil. Suppose network A and the massa that network A connects the device to are both evil. Yeah.
Go back. How many?
You're going to have to reread them.
Read the first question again.
Yeah.
Oh, yeah. All right. Maybe not possible to improve. This is from Henry Hertz. Maybe not possible to improve, but it seems like there are steps where the device is trusting things it doesn't yet know it can or should trust. How does it work? That is, it properly fails if network A is evil.
So how does it fail in this flow if network A is evil? So it completes 802.1x, and for whatever reason, massa hasn't issued a voucher, so massa hasn't done an audit log. It'll be device-side logic. So when it gets the voucher from the massa, it'll then have to go back and say, okay, well, I established an 802.1x connection to this TEEP server. I had to trust and first use for the TEEP server because I had no credential information or CE information to trust the TEEP server. It then completes the Bruschi flow. The Bruschi flow isn't going to voucher that network, and the Bruschi isn't going to audit log the fact that the network that's a device is successfully connected to that network. So it's going to be application error logic on the device to reject that network, blacklist it, and then go on to the next candidate network. So even though 802.1x authentication failed, after 802.1x authentication succeeded, Bruschi hasn't vouchered the network. Bruschi hasn't audit logged a success for that network. So the device is going to have to fail, reboot, try the next candidate network. It's complicated.
Mohit, no har. So what I think he's asking, and I have this same question, is why did the 802.1x authentication succeed in the first place? Why? So why do you get DHCP? You shouldn't get DHCP until 802.1x is successful. That's how 802.1x works. Unless you're authenticated, unless you trust the network. Why in the first place did it even try to connect with this SSID that it doesn't know? So you haven't solved the problem of connecting to the right SSID. You just assume that, oh, this could be this SSID I want to connect to, which is fine. But now you connect and you succeed.
That's exactly the problem you're trying to solve, though. When if you want a device, you unbox it, you power up for the first time, it does 802.11u or AQ or whatever, and it sees 20 candidate SSIDs and it does not know which one to trust.
Right. So it tries, right?
So it tries, right?
Yeah, which is fine. But then why in this it succeeds with 802.1x using IDEV ID?
So, I think we want to try to get through the mic line here, because we have some. This is not something that's in our current charter.
Right.
So
could you also go to the slide with the flying boxes? You had like 5 or 6 boxes in line. Yeah, this one. So how do I know which manufacturer to send it to? Right.
You'll know from your IDEV ID.
Right.
There'll be information in the IDEV ID telling you which.
Right. So now, I mean, 802.1x anyways requires like all your authenticators, access points, know which server to talk to, which is not specific to any EAP method. This is how 802.1x work. But now my TEAP server should also know which Bruschi registrar to talk to. And I guess there is different Bruschi registrars for different manufacturers. So I have to set up security associations with different manufacturers.
Well, the registrar will be on-prem. Generally, the registrar will be part of your infrastructure, and the mass is in the cloud, and the IDEV ID will tell you where to go.
But someone has to set up the security associations with different manufacturers. So that's an additional configuration step that I have to do in addition to setting up the access points, the server, and then the server to different master servers. So
and that's
I'm having a lot of flashbacks from when I was an area director long ago about EAP Fast and TEAP and whatever the other one was called. TTLS. I mean, TEAP is a protocol that is standardized by the IETF and went through the working group process. It was bloody as hell, but we did it. At the end of the day, it does sound like the proponents are trying to do the right thing by getting things standardized there. The other thing, Bruschi is a working group item for another working group, and they're asking for like, how could this maybe be done? I think that's a lot different than phrasing of like Cisco wants to do this. There's more than just Cisco people in that room, so I think we should consider that. You can maybe, say whether it's used or not, but at least it's being developed in the IETF, so it's not out of the blue. So I think we should probably consider that as well.
So, Sean, I think the tricky issue is that, and that's something I have complained about in the past, because there were various different provisioning protocols being worked on in the IETF concurrently. It was not just Anima, it was also Netconf with the Zero Touch, lots of fancy names, like what it gives the impression that you magically solve really hard problem as Zero Touch and no configuration, everything works out of the box. Where in reality, we just moved problems around. Instead of running the regular authentication AAA exchange all the way to the credential you have, in this case, the only credential you have is the manufacturer, we are now setting up that backend infrastructure with vouchers and everything else to get this working. And I think since it was done in Anima with all sorts of more like research efforts with whatever the other Anima dynamic network bootstrapping provisioning was, nobody really paid attention to that. And I think now we're getting closer to people like looking into this, including myself, figuring out what is this actually. And you, as you read through it, the document, you want to like, oh my God, all these claims at the beginning on what it does and what the problems are, and then later repeating the same issues. I feel I'm misled, to be honest, seriously. And I'm going to write this up because so you can be a little bit more specific about what I'm talking about.
Yeah, and I think that's a issue with Brewski, or I mean, I think those things need to be taken up with Anima or Brewski or whatever. I don't think that's a topic.
Well, so
go ahead.
Sorry, I'm wearing my AD hat. Can you tell me what you want, Owen?
What we want?
Yeah. So yes, what's the purpose of this presentation?
The purpose of the presentation is to define how to do Brewski inside of a TEEP tunnel at layer
Okay,
2.
so you would like adoption of this work in this working group.
Yes.
Good. Okay. So, as I recall, would be out of charter, so it would require a recharter. Is that correct, chairs?
Yeah.
So I guess my first question would be to the chairs, since we now would be contemplating a recharter. My first question to the chairs would be like, I've seen a bunch of presentations. There's like a bunch of work going on here already. So would you be able to take on this work if people wanted to do it? I'm trying to scope out like this. Like seems like there's like a pretty controversial technical discussion here, but like it may just be the case that like this is like not even like viable from a working perspective. So like I'm trying to sort out like the situation, right?
So it's a little difficult to tell right now because we're just bringing on.
Right. I mean, we just chartered you. I just chartered you like a month ago to do this, right?
I mean, the much of the work we have to do, I think, is fairly straightforward. When we get to AKA PFS, that's probably a little bit more work because there's more analysis that will need to be done. I think my concern here is just making sure that we clearly don't have a common idea of what Brewski is or what these other things are, and that's going to be difficult until we get that.
Sure.
For doing this.
Yeah, I'm just trying to figure out how to sensibly move forward in a way that that is helpful. I mean, how many more agenda items do you have here?
How long? We have it until.
Is this like the last thing, or
this is it? Yeah.
Okay. Yeah. Well, I guess people can like yell at each other for a little while longer then. But
Yeah. So, I've been reading the documents and following this discussion a little bit. I'm not sure I fully understand everything yet, but I just wanted to test if this mental model that I have built in my head is useful to understand this stuff or even correct. So the way that I think of this is that you have a very particular way of doing things, but what you essentially are doing is that you're trying to bootstrap a device, and the way to do that is that you essentially talk to infrastructure, and the infrastructure puts you in a sandbox of sorts where you can do enrollment using various kinds of different mechanisms, and then once you've completed that, then you can get out of your sandbox and possibly do like the proper thing. And that seems a fine thing on the sort of architectural level to do. I mean, lots of people do that sort of thing. I mean, many kind of networks, but of course, you have still many questions like, exactly what's the right level of doing this? Are you doing it at that EAP method level, or are you doing it inside a tunnel? Are you just, simply, letting somebody on a network and then they can do a manual or automated, regular internet exchange with somebody? Lots of choices, and they would have some impacts on what protocols need to be changed and such. And the other observation is I guess following up what Hannes said earlier, is that there's an issue here of moving, like if you have a problem, but you have to solve the problem even if you sort of move it into this sandbox stage. The sandboxes and your device still need to have an association of sorts, indirectly or otherwise, and that should be just recognized that's a necessary thing. But is this sandbox concept is that am I getting this right or getting it wrong?
Yeah, so the idea would be when a device first time bootstraps with its IDEV ID, it's put in some kind of sandbox network segment where it can continue provisioning and continue trust establishment. And then once it's been properly credentialed, then the AAA can put it in the correct network segment.
Yeah, and so in theory, if we ignore sort of efficiency or some other considerations, then you might just do like a regular network attachment on open sandbox networks SSID, and then you just do IP with a web exchange with somebody, and you wouldn't have to touch EAP at all. I mean that in theory seems equivalent.
So, well, actually, Brisky covers exactly that kind of flow, right? When you put on an open network segment, you can connect to a fallback vendor default registrar in the cloud, and the registrar in the cloud can then redirect you to the correct place or tell you to trust the correct network.
Okay, thank you.
And the Brisky flow also supports multiple different types of flows. So even if you're doing 802.1x to a network, the Brisky flow has multiple different modes of operation. One of them is where Brisky will just automatically voucher whatever information the registrar gives it, and just audit log the fact that it's vouchered this. Meaning you connect to any network, the network registrar was going to present its information to to the MASA. The MASA will just sign it and voucher straight away and just audit log the fact that this device is connected to this network. There's one mode of operation. Another mode of operation, which is a bit more complicated, and it's out of scope of Brisky how exactly this integration works. But via some kind of sales channel integration, if the MASA knows exactly where the device should go to, the MASA will not voucher the incorrect network. So the Brisky spec is pretty flexible on how this works, and it allows deployment operators different options as to how they want to deploy it.
So Max Pala, Cable Labs again. So I wanted to bring up a couple of points that have been made. So I think that according to me, it's clear that this is a provisioning thing. For .1x or in other environments could be used potentially. I have several use cases that we're actually going to work on, possibly for cellular network authentications, etc., where we deployed EAP. And I think a provisioning protocol, it could be in the scope of the working group, but as Ecker said, we might do recharter. In case we recharter and we accept this type of work, this could be initial work that can, be changed into what the work group direction wants to go. But I would really like to see a rechartering that includes the acceptance of provisioning through EAP. It could be done in this way. It could be with a generic EAP method that might support different provisioning, or it could be the acceptance of maybe other proposals that support different provisioning protocol that Anna said, Brisky has some assumptions that they don't respect, etc. We could address that, by supporting others as well, methods. But I think it's important work. I would support the discussion on this work because I think it's something that is important for devices to be able to get on networks or having some form of provisioning. There's many different networks, many different environments, WBA, CBRS, Multifier, that all have tried to solve the problem with adding, for example, OSUs, so onboard signing servers, something like that. And they all try to say, sandboxing in the network segment, try to do some exchange. That complicates network management a lot, and misconfiguration of that could cause the clients to access resources that they should not access. So the deployment of this type of solution, the sandbox solution, has always been very difficult and not really well deployed so far because we're very complicated. EAP, going through EAP would resolve many of the deployment issues, and I would say that would help a lot of provisioning secure credentials to devices. So I support the work. And I would like to see a rechartering that includes this type of work if the group approves. So we've been working so there's different 3GPPs currently is still not there. They support EAP, but they exclude anything else that is not AKA. However, in other environment, Multifier, CBRS Alliance, we just had the extended authentication document approved, and that means that we can use EAP, TLS, and TTLS for now. To do authentication for cellular network. This goes in the direction of addressing the problem of single SIM devices that we have today. So you can have multiple subscriptions or devices that do not support SIM cards because of licenses, fees, etc. would raise the cost of the device too much, but you still want to use, for example, 4G LTE networks to do, exchange data, etc. So there's other environment where this work could really be deployed and could really help the provisioning of these devices. That is the biggest problem today, to use other authentication method other than SIM, because SIM solves the deployment problem with the hardware. However, that's very costly. So trying to address that, I think is a good thing.
Brian Wise, Cisco. So I just want to reflect back on the fact that the main contribution of this draft is removing the sandbox, as we've been discussing. It's handling it all within the 802.1x, and it's either a success or a fail at the end, if it's been provisioned or not. The slide that Owen showed with the really complex device side workflow is really complicated, and it really, the main contribution is not about Brewski so much as it is bringing the provisioning and the enrollment into the method, so that it's a simpler process on both sides.
I'm Zhen Cao. I'm the minutes taker. I think it's pretty hard for me to take all to take down all the things for this discussion. But I think that's definitely necessary for use case draft. If you really want to push this forward within this group or elsewhere, right? Because I think what we have described, maybe there are some scenarios, but please tell us the use case so that I can do my job easier.
Sure, we can make edits to the draft and add some concrete use cases, as opposed to just diving deeply into the technical solution first, right?
So,
okay, there's nothing related to this draft. So Alan Decock from Jabber, he says that I owe the working group a draft to update session ID for fast reauthentication.
Oh, yes, thank you. So with this particular working group item, I think right now it's not in our charter, and I think the chairs need to go off, and we probably need to talk. Brewski's in Anima, is that the correct working? We need to talk with that working group to see where they're at, and because it's not the thing here, and looking at this particular slide, it's not just, it's an EAT method, but it's more than that. This is kind of an architecture, so it's a bit beyond kind of what the original sort of charter is in here. But if there's if this is the way, if there's some movement or consensus in the IETF to kind of move towards an architecture or support an architecture like this, then that could be within our scope.
Just Max Para, Cable Labs, just a small consideration. I don't think it's related to an architecture here. The question for this is, a change in the EAP method underlines an architecture, but the architecture is not in scope for the work. The scope for the work is changing an EAP method to add provisioning through EAP. And I wanted to ask the chairs if this, we can actually recharter, or getting a sense in the room and maybe in the mailing list, if you're rechartering about adding this type of work. So adding provisioning, credential provisioning through EAP, which seems to be solving a lot of different issues that I tried to explain before in many different environments, could be the new rechartering, and that will automatically include this work because this is not defining an architecture. The architecture is defined elsewhere. They're not changing anything right there. They're trying to transfer messages for provisioning. Can you confirm that, or is it?
Well, I can't, so I think there is an architectural change. It's not necessarily for this group to decide that change or not, right? And so we need to make sure that, I don't want to go through and spend a lot of time and argue a long time about what we're going to do here and then find out, well, Anima is not pursuing this direction, or, this is not something that there's consensus in the IETF to do. So
that's why I was trying to propose, not looking into the architectural change, but just the messages.
Yeah, but these things are kind of linked together.
This is Hannes. Just to elaborate on the architectural changes as far as I understand them. So previously, in using the Yaris sandboxing terminology, previously the sandboxing was at the application layer with this co-op, etc. HTTP proxy that was used locally, and now we are instead moving that layers deeper, as you can see also on this slide, at the EAP layer to make it more optimal or optimized in terms of the message exchanges. So this is an optimization to what was defined previously. I also just checked the IPR situation, so that's also maybe worthwhile to consider this in all the excitement. There's several IPRs filed on the Brisky stuff, so
Jarko. So, on the topic of like this working group working on the bootstrapping issue through EAP, I think that's potentially interesting. Although I personally would like to complete all the other work first, and maybe not surprising. But I have a couple of comments around like if we were to do that, then I think this working group cannot be responsible for the architecture. It would have to be somebody else, but we would still have to be convinced that we actually need the sandbox on our layer and that's a sensible architecture. I mean, even if somebody else works on it, but we have to, I think, would have to believe that for us to make for this to make sense for us. And then Max was commenting on the mobile networks and other systems that could benefit from more generally from bootstrapping mechanisms inside EAP. And I just want to highlight that there are obviously lots of different solutions in this space. I mean, and outside EAP also. For instance, in mobile networks, you have this hardware-less SIM cards of various sorts, and some deployment. I understand also. So it's not a space where nothing has been done in the past. So that should be kept in mind. Thank you.
So I think we can have some discussion of this on the list, although we really need to make our other work items a priority. So if this becomes a distraction, then we'll have to, take it off. But I think the next steps, I think the chairs need to we need to sync up with Anima and see where they're at. And then maybe talk with RAD and amongst ourselves, and then come back to the list and see where we're at.
Sorry, just one question. What is the criteria to define if this is a distraction or not? Because there might be some people that want to work on this and don't care that much about this other stuff, and that might not be a competition.
So you mean where to take the discussion if we can't have it in EMU? Is that the question?
No. I'm just saying, what is you just said, if this is a distraction from our work today, we have to, not accept this work. But what is the criteria there to say this is a distraction?
So, I mean, right now, this is not in our charter. So it's a distraction if we have discussion on the list that takes away if it becomes a contentious discussion and causes, problems within the working group. If it's people are spending more time on this than our chartered items, then that becomes a problem.
So, are you considering a recharting work to be in scope right now, or you're saying we are not rechartering, so we're not going to deal with these problems?
So right now we are not rechartering. We're going to look at, what would be involved in rechartering and why we would recharter. So we're looking at evaluating that.
Okay, thank you.
Thank you. Yeah, so typically, we can set up some time to